Hello everyone, I am Dr. Satish Mangal. Hope you are doing well. In this tutorial, we will discuss regression analysis. Regression analysis is one of the most important statistical techniques used to examine the relationship between a dependent, you may say outcome variable, and one or more independent, such that predictor variable. Unlike correlation, which measures only the strength and direction of an association, regression analysis also allows us to predict the value of dependent variable and estimate the effect of each predictor while holding other variables constant. The three most commonly used regression methods in SPSS are simple linear regression, multiple linear regression, and binary logistic regression. In this tutorial, we will discuss all three regression methods one by one. Simple linear regression. A simple linear regression is a statistical technique used to study the relationship between one independent variable and one continuous dependent variable. It determines whether the predictor significantly influences the outcome and provides an equation for prediction. There are certain assumptions while performing simple linear regressions. The assumptions are linear relationship between x and y such that dependent and independent variables should be there. The observation must be independent and distributed normally. There should be no influence of an outlier in the data. So to perform this, first we will add data. In this example, I want to know the impact of organic farming experience on soil organic carbon. So to perform, we will go to Analyze, select the regression and click on linear. Our dependent variable would be here organic carbon and independent variable will be organic farming experience. Click on OK. Now the interpretation. Model summary. The value R indicate correlation. In this example, the R value indicates a positive weak correlation between soil organic carbon and farming experience. R square. Generally, we consider R square into percentage. R square shows that about 15.7% of change in soil organic carbon is due to the farming experience, such that adoption of organic farming experience. ANOVA. T value here in this example is 0.000, which is less than 0.05. It indicates the regression model is significant statistically. Now the coefficient table. Here constant, we also call it intercept. The intercept is 0.377, indicate that the field predict organic carbon value 0.377 without adoption of organic farming. Slope, or you can say beta value. Slope 0.027 indicate for every additional 1 year of organic farming practice, the soil organic carbon increases by 0.027 unit on an average, and such a variation is statistically significant because the p-value again is less than 0.05. Now we will discuss multiple linear regression. A multiple linear regression examines the relationship between one continuous dependent variable and two or more independent variables. In this example, I want to know the impact of independent variables such that fertilizer use in kg per hectare, pesticide use in liter per hectare, rainfall in mm, mechanization index in percentage, net sown area in 1000 hectare, irrigation intensity in percentage, and cropping intensity in percentage on agricultural productivity over the time period for a particular district. So to perform this, we will again go to the Analyze, click on regression, and this time select also linear. My dependent variable would be agricultural productivity and independent variable will be from x1 to x7. Go to the statistics, select the estimate, model fit, collinearity diagnostics and click on continue. Press the OK. First, we will discuss the model summary. Again, R indicate a very strong correlation among the dependent and independent variables. R square indicate that about 99.9% of variation in agricultural productivity is explained by the independent variables taken in the study. The unavoidable, the t-value is again less than 0.05, which indicate model is fit and significant statistically. The coefficient table, constant value is 18.409. We can also call it intercept. The intercept indicate that about 18.409 quintal per hectare yield without taking all independent variable would be there. The beta values. Before analyzing beta values, we will check the significance. We can observe that the fertilizer use, pesticide and net sown area are the only variables which are significant, and the rest of variables are not significant because their p-value is more than 0.05 x1, such that fertilizer use in kg per hectare indicates with 1 kg per hectare increase in fertilizer, agricultural productivity would increase by 0.110 quintal per hectare, keeping all other variable constant. With 1 liter use of pesticide increases the agricultural productivity by 7.842 quintal per hectare, keeping all other variable constant. And in this manner you can also explain net beta value of net sown area. Before proceeding further, we should also examine the collinearity statistics. While performing multiple regression analysis, the chances of collinearity may be there. Under the collinearity statistics, tolerance and VIF, such that variance inflation factor, reflect that predictors are excessively correlated with one another, and such a correlation leads to the multicollinearity. For better results, the effect of multicollinearity must be negligible. In this case, now the question arises, what should be the threshold limit of tolerance and variance inflation factor to detect is there any multicollinearity or not? For tolerance, the value must be more than 0.01. In this example, the value of rainfall net sown area is more than 0.01, but both values are not statistically significant. On the other hand, variation inflation factor must be less than 10. The both value of tolerance and VIF indicate that in this example there is a multicollinearity effect. Now we will discuss binary logistic regression. A binary logistic regression is used when the dependent variable has exactly two categories. Keep in mind, exactly two, binary means two, such as yes or no, adoption or not adoption, etc. Instead of predicting a continuous value, logistic regression estimates the probability that an observation belongs to one of the two categories. Now the question arises, why we not use linear regression? Because linear regression can predict values below 0 or above 1, which is impossible for probability, because probability value lies between 0 and 1. So we perform logistic regression analysis to constrain predicted probability between the range of 0 and 1 by modeling the log odds of the outcome. To perform this, we will again add data. In this example, I want to know whether the adoption of organic farming is impacted by age of farmer, year of schooling, farm size, market distance, and number of family members involved in farming. So, to perform this, we will again go to the Analyze, select the regression, and click on binary logistic. Your dependent variable would be adoption of organic farming in this example, and covariate would be all variables. Go to the options and select Hosmer-Lemeshow goodness of fitness test. Click on continue and OK. This is our results. First, we will check whether our model is fit or not. Both Omnibus Test and Hosmer-Lemeshow Test have been performed to examine the significance of data and model. The finding of Omnibus Test shows that there is a significant improvement in fit as compared to the null model. You can see the significance. On the other hand, Hosmer and Lemeshow test indicate a poor fit. If the significance value is less than 0.05, in this case it is more than 0.05, the statistics of Hosmer and Lemeshow test also shows that the model adequately fit data as significance value is 0.822, which is more than 0.05. It shows that there is no difference between observed and predicted model. Keep in mind, the significance value of Omnibus test should be less than 0.05. On the other hand, the significance value of Hosmer-Lemeshow test should be more than 0.05. If both values such that for this one is less than 0.05 and for this test is more than 0.05 indicate goodness of data fit. Now the model summary. This is the model summary. Like R square, binary logistic provide two R square values, Cox and Snell R square and Nagelkerk R square. The model summary indicates that about 20.7% variation such that adoption of organic farming or not in this example is affected by the independent variables taken into the study. Now the interpretation of classification table. Classification table provides information regarding specificity and sensitivity of model in terms of predicting group membership on the dependent variable. The specificity for this model is 69.2%, which indicate about 69.2% of farmers do not prefer organic farming while selecting a farming practice. Variable of equations. First, we will check whether all variables are significant statistically or not. To check this, we will again go to the p-values and the p-values must be less than 0.05. In this example, only the age of farmer and year of schooling are significant statistically. So, we will provide interpretation for these two variables. Now the age. It indicates each additional year increases the odd of the event by 5%. To calculate in this example, I will perform 1.058 minus 1 divided by 100. In the same manner, year of schooling. Year of schooling indicate that each one unit such that 1 year increase in year of schooling, the odds of adoption of organic farming 24.5% and the effect is statistically significant. Means the year of schooling is the most important factor in adoption of organic farming in this example and affect the decision of a farmer whether he or she will adopt organic farming or not. In this manner, we can provide interpretation of binary logistic regression analysis. Thank you. Have a nice day.